I always like to do this summary when we're starting off pH because it's easy to lose track of what it's really talking about. And knowing approximately what pH should be also helps you know if you've solved the problem right. So I have these in order from largest to smallest. I just want to make sure that you're seeing this largest to smallest, like a 0.009 is larger than a 0.001. So make sure we're all good with that to begin with. So notice that they all have the times 10 to the 2. And then that one right there, those numbers are going down. So that's why I've got largest to smallest. All right, so to get to the pH of anything, it's just the negative log, remember, of H3O plus. So let's see what happens when we do this. So negative log of, we're going to do 9, and I'm going to use my E key. That means times 10 to the, and then I'm going to use my negative sign key and then the 2. I'm hoping you can see that. Let me pull it down if I need to. There you go. Enter. And so that tells me that my pH is 1.0, we'll say 5. Now I'm going to do the same thing, but I'm going to change that to an 8. And now it turns into 1 point, and if I look at like, if I'm trying to keep it to that many, that's 1.10. Now if I do this again and I change it to a 7, 1.15, and then I'm going to change it to a 6. 1.22. Then I'm going to change it to a 5. 1.30. I'm hoping you're starting to see something going on here. Change it to a 4. 1.39, so that's actually 1.40. Change it to a 3. 1.52. Change it to a 2. 1.70, and then I'm going to change it to a 1. So the first thing I want you to note is that if you have a 1 in the front, the positive form of the exponent is the pH. Now that would be kind of an unusual situation in real life to have exactly a concentration of like 1 or 1.0, but that's how that works right there. And notice that even though this is the largest concentration, you should see that pH, this is actually the smallest pH number. And this is the largest pH number. Also note that the smaller your pH, the more, and since we're talking about H3O plus, the more acidic it is. And the largest pH is going to be less acidic. Now, both of these numbers are actually still quite acidic, but the smaller the pH, the more acidic. So here's the thing that you want to notice, though, is that if you have an exponent of 2, your number is going to fall between 1 and 2. It's kind of like it's going to fall between, if that's n, it's going to fall between n minus 1 and n. So that's another thing to note about the pH. You can also think of pH like this, though. pH is like having a discussion instead of trying to compare things that might range from a scale of 1 times 10 to the first to 1 times 10 to the 14th. Instead of trying to have a discussion and try to compare, 2.22 times 10 to the minus third. And how does that compare to that number? Like those quantities are so large, it kind of gets to the point. And I could be doing this with negatives too, but it gets to the point where like the understanding of the differences between them, it's just hard to do. Kind of like how many cell phones are really around the world. Like if we say 1 billion versus 100 million, like what does that mean? What's the difference? So pH is kind of our way of talking about things that kind of helps us keep the same scales together. So if you have an exponent of 2, this helps you like kind of visually rank it. all running between 1 and 2. And you can know that, like, if you were to compare it to something that was 8, that's a big quantity difference. So that's actually what pH does. It kind of gives us a way to talk about our exponents. And in a way, it's kind of like comparing exponents. But just make sure that you realize that a larger concentration of H plus will lead to a more acidic solution, which is a lower pH. And that's because of the negative in the equation. Right there. They set it up that way.